Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and we are discussing on the falling stage systems tract. In last 3 lectures, we have discussed about the different aspects of falling stage systems tract. We have discussed about what happens during the early phase of falling stage systems tract. We have discussed about what happens during the late phase of falling stage systems tract, and we have discussed about the distribution of sand is to mud in different parts of the basin, which controls the potential reservoir conditions during the falling stage systems tract. So, in this lecture, we will continue our discussion where we left in the last class, where we were discussing about the potentiality of the petroleum play significance of the falling stage systems tract. So, already we know that during falling stage systems tract, condition varies from different areas within the basin, starting from the fluvial to the coastal to the shallow marine to the deep water part, depending on how much fall is going on, how much fall of the base level is going on, and how that particular area is responding to that. So, definitely in the fluvial part, in terms of the sediment budget, it is definitely very poor, because accumulation of sediments are relatively less over there, more erosions are going on. So, when sediment budget is poor, definitely reservoir potentiality is also very poor. If I talk in terms of the potential source and sill rocks, their chances are also very poor, because the deposition of relatively fine grained materials are very much restricted during the falling stage systems tract in the fluvial part. It is true if we are talking about the early falling stage systems tract or the late phase of the falling stage systems tract. So, overall we can negate the fluvial system as possible petroleum play significance, as possible reservoir potentiality. When we look into the coastal and the shallow marine part, it can vary significantly, because there we are getting significant amount of sand supply. So, there in terms of the sediment budget, it is fair, it is good, and there we are getting continuous supply of sediments. However, the nature of sediments, the type of sediments, that is varying significantly, and along with this sediment accumulation, their distribution pattern also varies, that we have discussed in the last lecture. So, depending on that distribution pattern, whether we are getting detached lobes, sand lobes, whether we are getting laterally continuous sand lobes, much thicker sand lobes. So, all these factors controls the possibilities of a petroleum reservoir, a hydrocarbon reservoir to form over there. So, in the coastal and shallow marine areas, what we expect in terms of sediment budget and in terms of possible reservoir, we can get good sediment supply, potentially sand dominated conditions, and that can act as a good reservoir, particularly when they are laterally connected or they are widespread. But when we look into in terms of the possible source and the sill rock, there the chances of getting these finer materials are significantly less, as during the forced regressive phase, as we have seen in our previous lectures, that the overall energy condition in the coastal and the shallow marine part, it is relatively high, and under such high energy conditions, chances of deposition of finer grain materials are significantly low, until and unless that area is covered later on by the self-fall mud deposits, self-fall fine grain deposits, maybe during a next phase, and that can act as a cap rock. In some areas, if you have the self fine material, the self mud deposits available at the base, and they can act as a good source rock. So, that possibility is also there, particularly when we are looking into the shallow marine part. In the deep marine part, it varies significantly from early phase to the late phase, because during the early phase sediment supply is high, but the nature of sediment is dominantly mud, because there we get dominantly mud flow. So, that cannot be a good reservoir. Though the sediment supply is good, sediment budget is good, but it cannot be a good reservoir. On the other hand, if I look into the late phase in the deep water part, there we get sandy turbidites. So, those sandy turbidites in terms of sediment budget very good, and in terms of the reservoir quality they can also be a good reservoir, because there we can get large sand bodies occurring over there. And in terms of the source and sill rock, that can vary depending on what are the distribution of the finer grade materials, what are the potentiality of deposition of the finer grade materials in between these coarser materials, particularly during the late phase. So, what we can observe during the falling stage systems tract, that the formation and the overall distribution of the reservoir phases, it may vary significantly. It can show different aspects between the stratigraphically lower part and the stratigraphically upper part of a single FSST. That is one peculiar characteristic of falling stage systems tract. So, the best petroleum clay that may form with respect to the late stage of forced regression are the sandy turbidites, which are commonly associated with the deep water submarine fans. So, these deep water fans where these reservoirs are forming, they are accumulating the coarsest parts of the basin floor fan and are commonly topped by the correlative conformity, because they are the last phase of deposition during the falling stage systems tract. So, they are commonly topped by the correlative conformity surface. So, the turbidity currents which are commonly triggered during the late phase of the falling stage systems tract at the self edge, because there now the delta is forming, there now the supply of sand is very high, at that point the energy condition is very high. So, those turbidity currents which are generating from that point, that self edge area along the slope, tend to have significantly high sand is to mud ratio. They also have significantly high sediment is to water ratio. That is why these are high density turbidites. Within these flows, within these sandy turbidity currents, large amount of terrigenous sediments are supplied by the fluvial systems, which are now reaching up to the self edge. So, this changeover during the late phase of the fall, late phase of the forced regression, creates a lot of difference in the deep marine part, which we cannot observe in other conditions. So, if I say for example, if I draw this, say this is the self area and then we are reaching over here the self edge, and from self edge we are reaching to the deep basinal part. So, at the late phase of the falling stage, the base level has reached over here, or maybe it is further going down and it is reaching over here. So, what is happening now? The river incision is going on at very high rate in this particular zone, and in response to that, huge amount of sediments are being supplied in this area, forming the self edge delta. This area is also a part of high wave erosions, wave activities, wave reworkings, and this reworking, these high energy conditions, maybe some storms are coming in over there. So, such high energy wave reworkings will lead to formation of or generation of successive turbidity currents, and for those turbidity currents the supply of materials is by the river, which is supplying sand, which is accumulating sand over here. So, if I draw a kind of block diagram, say if this is the self area and then this is the slope area and then we have the deep basinal part, this is the self edge. See, this is the river is coming in over here, incised river, and it is producing the delta lobe here. So, this delta lobe, which is this portion, this delta lobe is reworked by waves and currents, high energy waves particularly, and that will lead to formation of the sandy turbidites. So, these turbidity currents having very high amount of sand within them, carrying very high amount of sand, they will follow a channel path. So, they will follow this channel path and they will reach over here, and once they reached here, they will try to spread out, forming a splay. So, we get the deposition of sand or sandy turbidites within these channels and also within these splays. So, they will form the part of the submarine fan, where successive such splays of the sandy turbidites will get stacked one after another, forming thick sand deposit. When this channel is forming, what is the underlying material? That is basically mud, because those mud which have formed during the HST phase, or those mud which have been deposited during the early phase of the falling stage systems tract as part of the debris flow or mud flow. So, definitely for these channels we get a very well developed levee system. So, these channels they commonly create a very well developed levee system, as these high energy sandy turbidity currents they cut across the interslope these fine grained materials, and therefore they are deeper channels where we have very well developed levee. So, in this part we do not expect much spillover of the sandy materials, but they get concentrated within the channel itself, and once they reach to the basin floor, there they get spreaded over in the form of a splay, and there we get this thick sandy turbidite deposit. So, successive such sandy turbidity current that starts flowing from here along multiple channels, and they will come down over there, and overlapping splays will develop over here. So, laterally continuous as well as vertically they will be much thicker. So, that is the characteristic of the sandy turbidites forming in the deep basinal part during the late phase of the falling stage, provided at the late phase of the falling stage the base level has reached over here at the self edge or beyond the self edge. So, when this kind of channels are forming, producing levees in the upslope part and sand splays in the downslope area or along the basin floor. So, these channel fills on the slope and the frontal splays on the basin floor are dominantly sand rich, and hence they are potentially good reservoir rocks. So, effectively in the entire FSST, these sandy turbidites are the best reservoir rock that we can observe. Now, apart from these sandy turbidites which are forming in the deep basinal part, we can also find out some reservoir rocks with respect to petroleum occurrences in some other areas within FSST. So, additional exploration potential can be expected, can be found in other areas like the offlapping self edge deltaic lobes. As in the previous diagram, I shown you the successive delta lobes are forming at the self edge. So, dominantly they are sand rich because the river is supplying the sand, and those sands are accumulating as delta lobes, and as they will prograde along the continental slope, particularly in the upper part of the continental slope, so they can act as good reservoir rock. So, this is one possibility where we can also get a good reservoir to form during FSST, and the second one is definitely the strike oriented elongated sand bodies which have been abundant on the self area during the forced regression of the shoreline. The characters of these abundant sand bodies which are part of the either the delta lobe, previous delta lobe, or they are part of the previous shore face deposits or previous shoreline deposits. So, they can also act as good reservoirs. So, how they form, that we have already discussed in our previous lecture. So, during the formation of FSST in a basin, so basically we can find out a good reservoir, or rather good to fair reservoir can be found, can form in three distinct zones. One in the deep marine part where we can get sandy turbidites. Number two is along the self edge where a delta is forming and sandy delta lobes are accumulating, they are prograding. And the third one, the remnants the offlapping shore face sands or delta lobe sands which are lying, which are abundant on the shelf. They can act as the potential reservoir for petroleum. In the fluvial part, we do not expect any reservoir to form during the entire FSST stage, as I told you at the very beginning of this lecture, because there the non-marine portion of the basin is facing continuous erosion, downcutting and bypass. And in response to that, a subaerial unconformity is forming over there. Locally some pedogenic processes are going on over there, but we cannot expect laterally continuous sand bodies which may act as good reservoir. We do not expect deposition of some potential sill rock which can act as a cap. So, when all these factors are absent, we cannot expect a good reservoir to form in the fluvial system during the entire FSST part. Now, if I look into the other aspect, say for example, with respect to the coal resources, potentiality of occurrences of coal during FSST. So, the occurrences of or chances of coal formation during FSST is significantly poor, because the overall base level fall condition is not favorable for peat accumulation, because as the base level is continuously falling, the available accommodation is decreasing, it is in negative, and the non-marine environment, non-marine part is facing continuous fluvial valley incision or locally some pedogenic processes, paleosol development in the interflow areas, in the overbank areas. For the formation of coal, for the formation of pit forming mire, what we require is first of all a relatively low energy condition where the supply of terrigenous materials will be significantly low. The overall groundwater condition should be very high. That means there should be the overall accommodation should be higher, water level should be at higher level, higher condition. So, all these factors are not fulfilled during the entire base level fall during the fourth regressive phase in the fluvial area or even into the marginal marine area. So, with respect to coal resources, the entire phase of falling stage systems tract is not at all favorable for coal accumulation, or if we try to find out coal resources, it is not favorable, it is not possible to get good coal reserves, good coal deposits within the FSST. Apart from petroleum and coal, another very important resource can be found within the falling stage systems tract. This important resource is the placer deposits. So, placer deposits, they are commonly formed during erosions, during weathering, when some of the preferred grains, preferred minerals, they get concentrated in particular place. So, commonly surface processes are responsible, and during the base level fall, when this falling stage is going on, we commonly expect some surface processes to be dominant at certain part of the basin, and they can be significant enough, sufficient enough to produce good placer deposits at certain part of the basin. So, within FSST deposits or during the fourth regressive phase, we can expect some placer deposits to be associated with the FSST. The best area where we can expect this formation of placer deposits is the subaerial unconformity, because there erosion is going on, it is a high energy condition, and there the unstable materials, unwanted materials will be removed from the system, and those minerals which are having relatively higher specific gravity, they will concentrate in certain part of the river system. So, subaerial unconformities are the most important placer forming surface, because along this particular surface as the erosion is going on and reworking of the underlying high strength deposits are going on for long period, we commonly get concentration of certain placer elements, placer minerals to accumulate in this area during the formation of the subaerial unconformity. The reworking of these late high strength fluvial deposits, which is commonly more of a braided river type or maybe relatively higher energy meandering river type, is particularly prone for the development of significant lag deposits. Because in this kind of condition, when this erosion is going on, the reworking is going on, the amalgamated nature of the fluvial channels that accumulate under very low accommodation conditions, they are potentially important to result in the concentration of significant placer deposits. Because when successive channel deposits are accumulating, they are amalgamating with respect to each other. So, definitely in such cases the relatively high energy flow is going on through those channels and they will try to rework the already formed high strength deposits. So, apart from the fluvial system, apart from this kind of channel amalgamations, we can also expect placer deposits to form or get associated with wave scourings. So, that definitely will take place along the surface area or maybe in the inner self environment, and during this phase of fall when this forced regression is going on, so high energy waves are reworking the sediments in the shore area and that can produce other lag deposits. So, when we are talking about these lag deposits, they are nothing but the relatively heavier grains which the river system or the wave system cannot carry further and they are left behind, and when such left behind materials accumulate in a particular place, it forms a placer deposit. A very common example of placer deposit formed under wave scouring is the gold placers that we get in Witwatersrand Rand basin. This is one of the very common example. So, placer deposits can form by wave scouring towards the marine part. Placer deposits can form by river erosions, river reworking during river incision in the fluvial part. So, shoreline, this is the central element. This is the central element with respect to the nature of erosion, nature of reworking and the corresponding agent that varies. So, definitely the concentration of the placer deposits, the nature of accumulation of the placer deposits will also vary across the shoreline. So, shoreline is the central element in the exploration for placer deposits because it limits the lateral extent of all placer types. So, when we look into the subaerial unconformity related placers, they are commonly found only in the landward side relative to the end of fall paleo shoreline, because as the shoreline is gradually moving towards the basinward direction, river incision is going on, river reworking is going on, and as a result of that we will get accumulation of these lag deposits along the unconformity and it will continue up to the last point of the paleo shoreline, which is forming at the end of the fall phase. On the other hand, if I look into the wave reworked or wave generated placer deposits, they should be associated with RSME surface, the regressive surface of marine erosion, which commonly forms due to wave reworkings, wave erosions. So, we can call these placers as RSME related placers and which will form only towards the seaward side, and when they will form as soon as the shoreline starts moving. So, that is the onset of fall, from that point onward, onset of fall from when the paleo shoreline starts moving towards the basinward direction. So, depending on the position of the RSME surface during these successive phases of paleo shoreline shift, during these successive phases of base level fall, we can get placer deposits occurring and associated with RSME surface. So, if I draw the shoreline, say for example this is the shoreline. So, this is at time t1, the shoreline position is this. So, the river is incising over here and it is making subaerial erosions, and due to that subaerial erosion, due to that incision, we can expect deposition of the placer deposits along the river up to this extent. Now, during the fall, starting from 1 to say for example 2, this is the first phase, onset of fall, this is the end. So, this is the end of fall. So, the shoreline is reaching over here. So, when the shoreline is reaching up to this point, the river incision will continue up to this, and based on that we can expect the distribution of subaerial unconformity related placer deposits to be distributed up to this point. So, this is the end of fall paleo shoreline. Up to this we can expect the distribution of the placer deposits associated with the unconformity. On the other hand, when this falling phase started, again the onset of fall. So, during that time when the shoreline was here, wave reworkings were going on in this part, and in response to these wave reworkings we can expect RSME surface to form over here. As the base level will gradually fall, as it will gradually move towards the basinward direction, we can get successive RSME surfaces. And for each such surfaces, we can expect the distribution of the placer deposits associated with these RSME surfaces along this entire area, but it will start from the onset of fall. So, at the beginning of the fall, the position of the paleo shoreline will determine the RSME related placer deposits. So, basically we can expect the deposition or accumulation of these placer deposits across a very wide area, but we have to keep in mind that the nature of accumulation of these placer deposits will vary significantly across the position of the paleo shoreline. So, determining the paleo shoreline, and with respect to that the distribution of the subaerial unconformity and the RSME surfaces are very important to trace or to explore the placer deposits. So, depending on the distance between the paleo shoreline and the proximal rim of the basin, these placer deposits may not have a physical expression along the basin margins and may be missed if we continue the exploration solely based on mapping the basin margin unconformities. So, we have to look for the entire distribution pattern. Same is applicable when we look into the marine part, RSME related placer deposits, where again the shallow marine forced regressive placers that will overlie the RSME surface will develop only towards the offshore direction relative to the paleo shoreline at the onset of the base level fall. So, again if we do not consider this particular factor, we may miss some of the placer deposits during exploration if it is based solely on mapping of the basin margin unconformities. So, to conclude this lecture that we are continuing for last 4 sessions on this falling stage system strat. So, basically this is the manifestation of the deposits which form during the forced regressive phase when the base level is falling, and we have discussed about what are the mechanisms associated with such base level fall in different parts of the basin. We have distributed this area into the fluvial part, marginal marine part, shallow marine part including the shelf, and the deep marine part. So, we have discussed that what happens in the fluvial part where subaerial unconformity is forming, that subaerial unconformity will continue along with the continuity of the fluvial incision process as the base level fall continues, and it will affect the marginal marine area, and it may affect the entire shelf area where we can get the entire shelf area exposed, producing detached sand lobes formed at different phases of this falling stage. So, finally what we get, this kind of detached tan lobes preserved on the self area, a prominent unconformity with paleoshoals in the interfluve areas in the fluvial part, and self edge delta formed along the self edge area. Also we can get some deep marine mud flow deposits or sandy turbidite deposits, and depending on the distribution pattern of the sediments, depending on the distribution pattern of the sediment load and sand mud ratio, we have discussed that some of them, some of these areas, some of these units can act as a good or potential hydrocarbon reservoir. Also we can expect good placer deposits which may be associated with the erosional processes which is going on during the formation of the unconformity or due to wave reactions, wave reworkings going on in the salomarine part associated with the formation of the regressive surface of marine erosion. So, with this I will conclude this series of lecture on the falling stage systems tract. So, these are some of the references that you can follow for further reading. Thank you everyone.